Okay, now we're starting with number 14. We have to find all zeros, real and complex. So here we can expect to be getting an I in our answer somewhere. So the first thing we want to look at is, can we factor anything out from our polynomial? We can. We can see an x in all three terms. So if we factor out x, we get 5x to the fourth minus 17x squared minus 12. And if you look at this 5x to the fourth minus 17x squared minus 12, it's three terms. In the middle term, the exponent is half of the first. So that means we can use quad 3. And what we have to remember, though, is that this is not a true quadratic, it's x to the fourth. So when we use quad 3 and we look at the factors that they give us, we need to use x squared in place of x. Okay? So when we use quad 3, it's going to give us 5x plus 3 and x minus 4. So we want to write 5x squared plus 3 and x squared minus 4. And don't forget about the x out in the front. Okay, so now we have factored this down, and we need to put x equals 0, and then 5x squared plus 3 equals 0, and solve that. We're going to subtract the 3. We get 5x squared equals negative 3. Divide by the 5. We get x squared equals negative 3/5. And then we take the square root of both sides, and we will write x equals positive and negative, because the negative underneath the radical, that is now I, and square root of 3/5. Now, technically, we should rationalize that and do all that fun stuff, but I'm going to just leave that as is. Okay, and then x squared minus 4, set that equal to 0. Add the 4. I get x squared equals 4. Take the square root, and I will get x equals positive and negative 2. So I got x equals 0, x equals positive and negative I times the square root of 3/5, and x equal positive and negative 2. So 5 zeros there for my exponent of 5. When I look at 15, it's an x cubed, and there's only two terms, which should trigger in your head that we have a special factoring formula of a cubed plus b cubed. It's x cubed plus 5 cubed. And we follow the factoring formula of a plus b times a squared minus ab plus b squared. So we're going to have x plus 5 times x squared minus 5x plus 5 squared, which is 25. Now, the first term we set equal to 0, and we get x equals negative 5. The second factor, every single time you do the sum of cubes, difference of cubes, that quadratic that we get here from the second factor is always your complex. So we use quad 3 on the calculator, and when we do that, we will get 5 plus or minus 5i times the square root of 3 over 2. Obviously, you could use quadratic formula for that as well. And even over here for number 14, you could have done the quadratic formula. Again, remembering that if you used quadratic formula, you would have had to remember that it's not x equals negative b, plus or minus, etc. It's x squared equals. So you get down to the end, you have to take the square root of everything to get your answers. Let's move on to number 16. Number 16 is just like number 14, where you have a quadratic format. So we could use quad 3 again, or a quadratic formula, but we're using x squared in place of x. So quad 3 using x squared. Okay? So when we use quad 3, we will get 5x plus 1, and we need to convert that to 5x squared plus 1. The other factor is x minus 1, which we convert to x squared minus 1. So when we set each one of those equal to 0, subtract 1, 5x squared equals negative 1, divide by 5, x squared equals negative 1/5. Take the square root, and we get x equals positive and negative. Because of the negative underneath the radical, we have an I, and then we have the square root of 1/5. Again, you can rationalize it, but I'm not going to worry about it. X squared minus 1 equals 0 is the other factor. I add 1. I get x squared equals 1. Take the square root. I get x equals positive and negative 1. So I have factors of positive and negative I times the square root of 1/5, and also positive and negative 1. Now let's look at number 17. We have 4 terms here. If I try to factor by grouping, it will not work, which means I have to use P over Q, make a list of possible zeros, and go from there. So I have factors of 12. So 1, 2, 3, 4, 6, and 12 over the factors of 2, which are 1 and 2. So from that, I get positive and negative 1, positive and negative 2, positive and negative 3, positive and negative 4, positive and negative 6, positive and negative 12, positive negative 1/2, and positive negative 3/2. So that's just doing that list just like we've done in many other problems. Um, Now we start synthetic division. And if I try 1, let's see what happens. I get 2, negative 7, 7, negative 12. I bring down the 2, multiply by 1, I get 2, add, I get negative 5, times 1, negative 5, add, I get positive 2, multiply, I get 2, and add, I get negative 10. All right, it wasn't a 0, but when I look at my outcome, I got positive, negative, positive, negative. That means this is a lower bound. So that means I don't want to try positive 1/2 or any negative numbers. Okay, if I try 2, 2, negative 7, 7, negative 12, I get 2, 4, negative 3, negative 6, 1, 2, negative 10. Okay, well, that worked out as a lower bound as well. So now I don't need to check the positive 3/2. So apparently 2 is a better lower bound than the 1, right? So now we try 3. 2, negative 7, 7, and 12. I get 2, 6, negative 1, negative 3, 4, 12, and that's a negative 12 up there. So I get 0 down here. Okay, so that was a 0. So now, because I started with an x cubed, this is a quadratic down here. 2x squared minus x plus 4. When I use quad 3 or the quadratic formula, I will get 1 plus or minus I times the square root of 31 over 4. And so therefore, my zeros are 3 and 1 plus or minus I times the square root of 31 over 4. Okay? And now let's look at number 18. This says, find the polynomial with integer coefficients that satisfies the given conditions. We want a polynomial that has a degree of 3 and zeros of 2, 3i, and negative 3i. So here they gave us both of our complex values here. If they just gave us 3i, like if I scribble that out right there, so if I have this, I need to remember that negative 3i has to be a part of that because you always have a positive and a negative going along with your complex zeros. So here it was given to us and we didn't have to worry about that. But we're going to take each one of these zeros, and each one of these zeros is the C value. So your zeros are the C value, and the factors are created by doing x minus C. So x minus the 2, x minus the 3i, and x minus the negative 3i, which gives you x plus 3i. We're going to multiply these all together. We're going to multiply these two first because those work together. So x minus 3i times x plus 3i is going to give you, you have a plus b and a minus b. So your result is a squared minus b squared. So a plus b times a minus b is equal to a squared minus b squared. So x squared minus 3i squared is x squared minus 9i squared. And I squared is negative 1. So this is going to convert the minus 9 to be plus 9. So you get x squared plus 9. Because that would be like negative 9 times negative 1 to get positive 9. Now we're going to multiply that times the x minus 2. So here you could do FOIL method or the box method. You're going to multiply, you get x cubed minus 2x squared plus 9x plus, nope, minus 18. I cannot combine any like terms, so my polynomial is x cubed minus 2x squared plus 9x minus 18. That is a degree of 3, and we have all integer coefficients. And that is it.